Hey everyone, Radhe Radhe. My name is Ayan Pravesha. I'm the Cloud Native Developer Advocate, and today we'll start taking new there is the examples of gateway APIs. In the last lecture, in the last video, you might have heard and learned a lot more about the gateway APIs and the normal orchestration and the management of our Kubernetes and cloud native stack. We tried to take some of the examples from the gateway APIs. We try to explain about the various components of gateway APIs and what are the benefits of using a gateway API over the Ingress model or Kubernetes, the normal application that has been built on the basis of the clouds. So today we'll be taking one of the implementation, one of the tools that usually have took gateway APIs, have adopted gateway API in its architecture, that is the Cilium. It's a really important and really popular project that every cloud native fan or the cloud fan might have heard somewhere at some time in his life. So Cilium has a service mesh, as a gateway API branch as well. Cilium Ingress Gateway API, and the other one is the Cilium Egress Gateway API. In the next lecture, we'll try to explore more about the Ingress Gateway API of Cilium. In this lecture, we'll try to restrict ourselves to the Ingress Gateway API, because recently we have tried to look into the Ingress as well as the Gateway APIs. Alright, so the Cilium already uses the Envoy for its layer 7 policies and the processes for the observability and some of the protocols as well, like by using a sidecar in many popular service mesh implementations as well. Cilium has always been in favor of the Envoy Proxies, but it's kind of restrict itself from adopting the sidecar model of the Envoys, or the service mesh. What are those particular reasons? Today we'll try to look into all those particular reasons and how it is dealing with all of them. So yeah, here's the whole the diagram of Cilium service mesh. It gives provides some of the features, that is the traffic management, observability, security, reliance, as well as it also uses a lot of different tools that are being available at the moment in your cloud stack, like the Prometheus, Grafana, Fluently, and the open telemetry for the observability part. For the control plane, you might have it can use some of the CRDs or the Kubernetes distributions as well, the Ingress or Istio gateway APIs, Kubernetes gateway APIs. And when it comes to the data plane, you have two particular options: whether you can stick to the the most kind of adopted sidecar model of Envoy, or otherwise you can came on to a newer adoption of handling all of these particular service mesh or the sidecar models, the proxies that is the eBPF native, and the other, and along with the Envoy sidecar less model. So let's try to look into all those particular features. Benefits that are available while using the Cilium gateway APIs is that, like when we extend our Cilium with the service mesh features as well, it obviously offers a lot more features commonly associated with the service mesh. Instead of just Envoy is embedded with the Cilium, Cilium will try to, instead of producing each and every particular sidecar proxy for all your resources, Cilium will try to build or attach only one particular node and only one particular Envoy container for the whole node, for carrying out your the Envoy proxies and the service mesh kind of the functionalities of processes that are running or being handled in your container at the moment. So in the eBPF application, it is typically service mesh. So all the network packets need to pass through a sidecar proxy. If it is a default sidecar model, it will have to pass through a sidecar proxy container on their path to or from any particular application, and this way it will pass from the TCP and TCP/IP stack layer for 3 times. That is from the application, then it will enter into the sockets and TCP and all, then will pass through the service mesh when it is get approved, and then it will enter into the physical layer or your container that is actually being running of that particular instance of your application. So it will add up a lot of cost, a lot of memory as well, and a carbon footprint. So obviously it won't be a really sustainable feature for your application, to be honest. In service mesh, we are moving the proxy containers onto the host and kernel, so that sidecar for each application pods are no longer required, because eBPF allows us to intercept packets on the sockets uh, as well as our network interfaces as well. Cilium can drastically shorten the overall path of the packet, so that's one of the really amazing feature, to be honest. And like uh, there will be only one particular sidecar model that will be like the service mesh or the proxy, Envoy proxy that is running in your particular node for all the resources that are being configured into with your application, being deployed onto that particular node. So only one Envoy proxy would be available, would be handling all these particular resources and the Envoy proxy features and the processes, instead of attaching all the resources with different the Envoy proxy solutions as well. So instead of doubling the resource and the computational overhead, we can just move on to adopting just one of those the Envoy proxies instead of getting a lot of them. It will be really helpful in the sustainability initiative as well. Save up a lot of memory, save up the cost cutting part as well. And for every instance of our application in the backend or front end, um, like we won't have to manage the different libraries or the different the service or the sidecar models for all of those particular features. So earlier we used to have our application, and then all those particular applications were written in different codes, whether it was the Go, Java, or Python, Rust, Ruby, etc., or various different languages, the computational languages as well. So for all of those particular languages, you have to attach particular framework to understand the code that was being written by you in that resource. And then while using that particular library, then you can process for the particular the action that we are looking for to being accepted by our application. So to conquer that, to handle that particular situation, the sidecars model was introduced, which essentially moved the mesh library into a sidecar, and thus we no longer need a language specific library into our application. Cilium have been trying to avoid sidecar proxies for every service resource created in the pod. Cilium is with running one proxy per pod, or one per namespace, to be honest. So also Cilium does have service mesh integrations from the starting of its journey, and Cilium has been moving and implementing this particular idea of adopting the service mesh into the operating system itself, so that it could be transparently available for your operating system without needing to run any additional sidecar processes, and save up a lot more computational power for your operating system as well. So we will have a service mesh sitting as a part of our network stack in our operating system, our TCP and IP layer. And for the sustainability, here's the graph. You might have seen somewhere on the screen. So as you can see, the sidecars are expensive to inject, obviously, in parallel with all the nodes, pods, resources, namespaces, and services, because they have to pass through the network stack with multiple times with such a high costs. As I said, they have to pass through the TCP and IP stack layer, TCP and IP stack layer for 3 times. That's from the request that has been made first of all, and then it will have to pass through the network layer and the Envoy proxies that are available on the sidecar service mesh that are available at the moment. We have to enter over there, and then will pass through that proxy, and then will enter your application. It will be a lot more tedious kind of a work, will take up a lot of time, as well as also won't help you at all in cutting the cloud costs of your resource, of your application, and will eventually bring a lot more troubleshooting part as well. And can also become a security threat for your application as well, for your organization. It won't be helpful in the troubleshooting part either. So we'll take a lot more time, we'll waste a lot of the carbon footprints as well, will produce a lot more carbon footprints. Sustainability won't be good, memory part will always be an issue for your application. And yeah, that isn't a really good kind of view, or kind of an investment from any particular project manager or the maintainer. So his was all about the Cilium Ingress Gateway API. In the next lecture, we'll try to address some of the features that are available by the Cilium Ingress Gateway API, and then we'll also try to look into the lab session as well of our application. So yeah, that was all about the Cilium Gateway API, Ingress Gateway API. If you really want to know more about such particular kind of the solutions that usually oppose the sidecar models, then you can also look into the ambient mesh instead of the service mesh. I'm giving you another hint. Instead of service mesh, we also has an ambient mesh that has been developed with the help of the Solo.io and the Istio. They have worked really hard on this particular project, and it's an amazing project, to be honest. If you really want to know more about the ambient mesh, you can look into one of the podcasts that I held earlier with Lin Sang, and also she and Christian Posta have written a book all about this sidecar-less model of the Istio. So that's also a really interesting topic that you can read that book as well. So yeah, that was all about our today's session. See you soon. Radhe Radhe.